right, so if you're in the class or you've just been following along with the videos or watching the videos, so far we've talked about solving systems of equations. By graphing or substitution. So graphing, we just graph the things and saw where they intersected. Substitution, we had two equations. We substituted part of one of the equation and for the other equation, and we got an answer. But the last type that we're going to talk about today is elimination. So another way of solving systems of equations. And I'm going to show you guys how to do this. So once again, you're going to see a system of equations like we do here. We have x minus 2y equals negative 19, and 5x plus 2y equals 1. So the first thing that we're going to do is we're going to modify the equations so that there are two opposite terms in each equation. Now, a little later on, we'll actually be concerned with this step, but actually, to start off the problems right away, we won't need to do that. So what I mean by there are two opposite terms. There's going to be one term that is positive in one equation. There's going to be a term that is the opposite sign in the other equation. So if you notice how this one, I have a negative 2y and a positive 2y. Okay, so those are what I'm talking about, opposite terms. So we want to see that in elimination problems. Always, always, always in elimination problems. So the second step that we're going to do is we're going to actually add the two equations together. So it sounds kind of strange, and you'll see what happens. So I like to make a little line here, and I actually like to make these little vertical lines here so you know what you're adding together. The x and the 5x will give me a 6x. Now the negative 2y and positive 2y, because they are opposites, I'm just going to cross those out. So that's just going to zero out. So 6x is just going to equal, well, negative 19 plus a 1 will give me a negative 18. Okay, so that was step 2. Step 3, now solve for the first variable. So 6x equals 18. So if I divide by 6 on both sides, x is just going to equal negative 3. So we have negative 3 for an x value. So that was step 3. Now step 4, plug your answer in for the first variable. So as we have our negative 3 here, into one of the equations to find the other. So this is the exact same step as what we did on substitution. Once we found one, we just plugged it into one of the equations to find the other. And I kind of wrote all over it, but once again, use the easier one. So I don't know, depending on your preference, looks like the top one might be easier. So negative 3 minus 2y is going to equal negative 19. And then just solve for y. So we're going to add 3 on both sides. So a negative 2y is going to equal a negative 16. And then dividing by negative 2 on both sides, I'm going to get a y equals 8. So once again, write your answer as a coordinate. So the point negative 3, negative 8 is my answer for that one. So the next example here. Once again, we don't have to do any modifying because if you look, I have a positive 3x and a negative 3x. So let's add those together, the two equations. Y plus a 2y will give me a 3y. 3x and a negative 3x will cancel out. So 3y just equals a 12. Okay, so once you get the pattern of these problems, they actually go by really fast. Now solving for y, divide by 3. So y will equal 4. And choose one of the equations to plug that 4 in to find the x value. The top one looks pretty easy to use, so plug in 4 for y. So 4 plus 3x is going to equal a negative 2. Let's subtract 4 on both sides. Okay, so 3x is going to equal negative 6. And then dividing by 3 on both sides, we get x equals negative 2. So the point negative 2, 4 is my answer. Once again, the next one, I don't have to do that first step because if you notice I have a negative 4y and a 4y, so those when I add them together will cancel, so we'll be okay. 3x plus x will give me 4x. Those zero out. 10 minus 2 will give me an 8. Solving for x, divide by not 2 but a 4, and x will equal 2. Choose one of the equations to plug that 2 in. I can plug in that 2 in for x on the bottom one. So let's do 2 plus 4y equals negative 2. And then I can subtract 2 on both sides. So 4y is going to equal negative 4. And then I can divide by 4 on both sides. So y will equal negative 1. So the point 2, negative 1, is my answer for that one. Okay, so here's another example of elimination. So if you notice on this one I have a positive x and a negative x. Those terms will cancel out when I add. So those are going to zero out, x and negative x, so I'm not even going to write anything. And then the 5y plus 2y will give me a 7y. And then 28 plus 7 will give me a 35. Solving for y, we divide by 7 on both sides. So y will equal 5. And then finding the x value, plug 5 in for y. Let's use the, then it doesn't matter which one you use. Let's use the bottom one. So we have a negative x plus 2 times 5 equals 7. So negative x plus 10 will equal 7. So let's subtract 10 on both sides. So we have negative x equals negative 3. And you can divide by negative 1 to get rid of that negative 1 in the front. So x will equal positive 3. So the point 3, 5 for this one. So here are some problems where you notice how we don't have opposite terms. We almost do. We have a negative 10x and a negative 10x. So we want to have a positive 10x, and at least one of them to be positive, one of them to be negative. And in this case, we don't. So these problems, we have to actually multiply by negative 1 on one of the equations. So going back to the steps that we talked about, this is the step 1 I'm talking about. So we need to modify one or both of the equations. In this case, you only have to modify one. So what you're going to do with these kinds of problems is just pick one that you're going to multiply by a negative 1. So it doesn't matter, top or bottom. I can either make the top one positive or the bottom one positive, because remember, a negative times a negative will give you a positive. So let's do the bottom one. So I like to put parentheses around it, put that negative 1 right there. So basically multiplying by a negative 1 just flips all the signs. So a positive 10x, a positive 9y equals a positive 28. So I'm not going to use this equation anymore. I'm going to use the top one with my new one. And when I add those together, the negative 10x and the positive 10x are going to cancel out. I have 6y plus 9y gives me 15y, and that equals 30. And then divide by 15 on both sides. That'll give me a y value of 2. So y equals 2. And going back to one of the equations, you can use the one that's actually scribbled out if you really want to. Finding one of the equations to use. So just plug in 2 with whatever one you want to use. Again, use the easiest one. Just make your life easy. Looks like this one might be the easiest one to work with. So 10x plus a 9 times 2 equals 28. Okay, 9 times 2 will give me 18. And I have a 10x out front here equals 28. Subtract 18 on both sides. I get 10x equals 10. And dividing by 10 on both sides, I get an x value of 1. So the point 1, comma 2 will be my answer for that one. All right, so we have another problem where if you look closely, we have two terms. They're almost opposites of each other. The only difference is that the signs are the same, so we need one of them to be negative in this case, if we look at the two y's in each equation. So again, pick one of them to be negative. Let's pick the top one this time. We'll multiply by -1. So I'm going to rewrite this one below. And again, when you multiply by -1, that just flips all the signs. So we have a -8x minus 2y, and that equals a +6. So now we have to add these two together. So -8x and an x, that'll give me a -7x, and that equals a 0. So divide by -7, I get that x will equal 0. Okay, so we have x equals 0. Go back to one of the equations, plug a 0 in. Looks like this one might be the easiest one to use. So we have 0 plus 2y equals -6. Now the 0 is just going to cross out, so we get 2y equals -6. Divide by 2 on both sides, I get y equals a -3. Okay, so we have the coordinate 0, -3 for that one. Going on to the next. Looking closely at this one, I have a -2y and -2y. Again, one of them's got to be positive. So let's choose one to multiply by -1. You can use the top or the bottom, either one. So multiplying that -1 through, I'm going to get a -4x, positive 2y, and -24. So I'm just going to scribble that one out for a sec. Adding that top one and that third one together, I get that, well, just an x equals 2. Okay, so I'm actually done there. Well, x equals 2. Then going back and choosing one of the equations to plug it into, again, doesn't matter. Let's use the first one here. So 5x minus 2y equals 26. I need to plug in the 2 in for x. So 5 times 2 minus 2y equals 26. 5 times 2 gives me 10. Minus 2y equals 26. Subtracting 10 on both sides, I'm going to get -2y equals 16. And dividing by -2, y will equal a -8. All right, so we got the point 2, -8 will be my answer. So a different type of problem that you're going to see, if you look at the equation, I have the terms 10x, 6y, 4x, and 3y. I don't have that opposite term thing going on, but I also don't have, like we did in the previous problems, where I had like a 10x and a 10x. So I just need to multiply by a -1 on one of them. So here we're going to get into some problems where we're going to multiply by a number in just one of the equations to get that cancellation to happen. So you can just multiply an equation by a number, and it's okay to do that. So different looking equations will actually give you the same graph, or will behave the same way. So taking a look at this, remember what your aim of the game is to get opposite terms. So is there any way I can multiply 4 by something to get, let's say, a -10x, or is there anything I can multiply 10 by to get a -4x? Yeah, there isn't really anything that works. So maybe let's look at the y terms. So I have a 6y and a -3y. Well, first off, one of them's negative and one of them's positive, so we're good there. Is there anything I can multiply by the 3 or the 6 to get that cancellation to happen? So you might be thinking that, well, hey, I can just multiply -3y by 2. And what that's going to do is that's going to give me a -6y for that middle term. So we'll get that opposite to happen. So 8x minus 6y will equal a -2. So we're going to go ahead and do that. Now, these won't actually just jump right at you. You kind of have to play around with it to get those opposite terms to pop up. But once you have that, then all you need to do is add it together. So 10x plus an 8x will give me 18x. 6y and -6y, those will cancel. So negative 16 minus 2 will give me negative 18. And dividing by 18 on both sides, I get that x will equal negative 1. And once again, choose one of the equations to plug that negative 1 in. Let's use this guy. So I have 8x, or rather, not 8x, but 8 times negative 1 minus 6y, and that equals negative 2. So 8 times negative 1 will give me negative 8, minus 6y equals negative 2. So adding 8 to both sides. So I got negative 6y, it's going to equal 6, and dividing by negative 6 on both sides, I'm going to get a y value of negative 1. So the point negative 1 will be my answer for that. So looking at a few more of this type, looking at the first, or not the first one here, but this system, you got to look at the x's or the y's. Is there anything I can multiply, or any number I can multiply by one of the equations to get some sort of cancellation to happen? Now remember, you can multiply by a positive number or a negative number. So if you look at the y's, there isn't really anything I can multiply the 7 by to get a positive 9, or there isn't anything I can multiply by the negative 9 to get a negative 7. So let's take a look at the x's. And you might see that, oh, I can just multiply the x by a negative 3. And that's going to give me a negative 3x up on top. So let's go ahead and multiply that. Negative 3x minus 21y will equal a positive 60. And then I'm going to scribble this guy out for a sec. Add these two equations together. So the x terms are going to cancel out. I get a negative 30 y will equal 90. And dividing by a negative 30 on both sides, I get y equals a negative 3. So y equals negative 3. Let's look back at one of the equations and plug in that negative 3. And for y, let's maybe use that middle one. So I have 3x minus 9 times negative 3, and that equals 30. So negative 9 times negative 3 give me a positive 27, and that equals 30. And subtracting 27 on both sides, I get 3x is going to equal positive 3. And divided by 3 on both sides, I get x equals 1. So the point 1, negative 3, is my coordinate for that. So another of this type of problem, looking at the x terms or the y terms, trying to get some combination of canceling it out. You can look at the x terms and say, well, I can multiply the top one by 2 because that'll give me a negative 20 on top. Or you can multiply the top by a negative 8 if you look at the y terms, because then that'll give me a negative 8y on top and a positive 8y on bottom. But I kind of like to keep it simple and kind of smaller, so why don't we just use multiplying by 2. So multiplying through on the top equation, I'm going to get a negative 20x plus a 2y, and that's going to equal negative 44. So adding that together, the x terms will zero out. I got 8y plus 2y, that'll give me a 10y. And that's going to equal a negative 20. And then dividing by 10 on both, I get a y equals negative 2. So y equals negative 2. So I got to plug that into one of the equations and get the x value. So let's actually use, and kind of ignore the parentheses here, this one right here looks pretty easy to use. So negative 10x plus a y, or minus 2, that'll equal a negative 22. Let's add 2 on both sides. I get negative 10x equals negative 20. And divided by negative 10, I get that x equals a positive 2. So the point 2, negative 2, is my answer. So the last type of problem that I'm going to talk about are systems where you actually need to multiply both of the equations by a number to get it to eliminate. So and these can be kind of tricky. But if we look at, let's say, the x terms. So is there a number, of course there is a number, but a number that you can use that is a multiple of 9 and 5. Okay, so you could use 9 times 5 will give you 45. So one of the equations would have a positive 45. One of the equations would have a negative 45. I want to encourage you guys to actually use the smallest numbers as you can. Like instead, why don't I just look at the y terms? Okay, 2 and 3, I could use 6. Then I would only need to multiply one of them by a 3, one of them by a 2, and then I need to make one of them positive. So I'm going to make a positive 6y term in one equation and a negative 6y term in the other equation. So this one, how about let's make that the positive one. So I need to multiply that one by a negative 3. So I'm going to have a negative 27x plus a 6y, and that's going to equal a positive 8 times 3 will give me 24. And then to get a negative 6y, because I need to cancel out with that 6y, let's multiply that by a 2. So 10x minus 6y, that's going to equal 10. Okay, so notice what happens. Okay, we want that to happen, remember, in all of our elimination problems. Both equations have opposite terms. So when I add those together, I'm going to get a negative 17x equals 34. And dividing by negative 17 on both sides, I get x is going to equal negative 2. So there we go. Now you kind of have a choice here of lots of different equations. You could use our two new ones, either one of them, to plug that x term in. You could also use the original ones, of course without that negative 3 and 2 in front, if you wanted to. Looks like this one right here might be our easiest one to use. So let's plug in negative 2 in for that one. So I got 5 times negative 2 minus 3y, and that equals 5. So negative 10 minus 3y will equal 5. Adding 10 to both sides, I get negative 3y equals 15. And then dividing by negative 3 will give me a y value of negative 5. So the point negative 2, negative 5 is my answer for that one. And the last one that I'm going to do in this video, so look at the x and the y terms. So you could play with the x terms. You could use with 6 and 4, you could use 12. There isn't really any rhyme or reason on whatever numbers you want to use. If you look at the 5 and 2, you could use 10. So it's just kind of up to you. On the last one, we used the y term. So maybe let's use the x term on this one. So I have 6 and negative 4. So I need one of them to be a positive 12, one of them to be a negative 12. So let's multiply this one by 2. That gives me 12x plus 10y equals 2. So remember, it's not going to pop at you. Use your brain. And I need to multiply this one by a 3. So negative 12x, remember, this is what we want to happen, right there, minus 6y, and that's going to equal 18. Let's add these together. So the x terms are going to cancel. 10y minus 6y gives me 4y, and that equals 20. And dividing by 4 on both sides, y is going to equal 5. So let's plug 5 into one of the equations. Looks like this one might be easiest one to use. It's kind of up to you. Maybe you want to use another one. But 6x plus 5 times 5, plugging in that 5 in for y, that equals 1. So 6x plus 25 can equal 1, subtracting 25 on both. 6x will equal a negative 24. Dividing by 6, x is going to equal on negative 4. So the point negative 4, 5 is my solution for that one.